theory you have to think about is when energy is being transferred, the transfer of energy from one store to another is never complete in reality. There is always some wasted energy that doesn't end up where it's supposed to. Okay, so we talked about something, driving a car. If you have ever, or riding a bike, if you've ever touched the wheels after a journey, you will notice it gets hot. And that is wasted energy, and it is because the car or the bike isn't 100% efficient as a machine. It's impossible for anything to be efficient. So, using our example of the car, you start off with chemical potential energy stored in the fuel or the petrol. As the car drives, the amount of energy stored in fuel or chemical potential decreases, and the amount of kinetic increases because the car is moving. Okay, but not all the chemical potential will end up in a kinetic store. Some of it will be wasted as heat energy or thermal energy. Okay, so that happens because there is friction between moving parts inside the car or the bike or anything else, and that causes work to be done against friction. Okay, doing work means transferring energy. Okay, so the car is doing work in order to drive, and it's also doing work against friction, and both those things need some of the energy from its chemical potential store. Okay, and we can talk a nice phrase that they like in mark schemes, energy being transferred to a thermal store in the surroundings. It's a little bit more scientific than wasted as heat. Okay, and this phrase, work done against friction, that is why energy is wasted. You've also got the idea of conservation of energy. Energy can be neither created or destroyed. It can be only transferred from one form to another. So energy cannot be created. It cannot be destroyed. Okay, so all that energy in the petrol, it's got to go somewhere. Whether that is an explosion, if the car was set on fire, whether that's the petrol being burned in a controlled way as it's used, or whether that's petrol just sitting there and storing the energy for a long time, the energy will never be destroyed. If you run out of petrol, you can't simply make more energy. You cannot create it. And that word created, I will say, by the way, is a word that we try and avoid using in science. Okay, you can say produced or something like that, but unless you are saying that energy cannot be created, you should avoid that word created in physics. An example of a pendulum. If this was 100% efficient, which it can't be, okay, so if there was no friction where it's suspended from something and there was no air resistance, it would simply, once you set it going, it will simply swing back and forth forever. So at the highest point of its swing, it will have maximum gravitational potential energy. As it swings down to the lowest point here, it's got least gravitational potential and most kinetic, so that will be where it's going fastest. As it swings back up, it loses kinetic and gains gravitational potential. And in fact, at the very top of the swing, it's lost all its kinetic. It will pause for a fraction of a second. So energy constantly being transferred back and forth between gravitational potential, kinetic, gravitational potential. Because of friction, because of air resistance and work being done against them, some energy is wasted on each swing. So the swings will gradually get smaller over time. And that is because work has been done against friction, so energy has been transferred to a thermal store in the surroundings. So the air around the pendulum will get slightly hotter. The string, particularly where it connects to what it's being suspended from, will get slightly hotter. The other key idea that you need to have is power. So power is how quickly you do work or how quickly you transfer energy. So more powerful things transfer energy or do work in a shorter time. So if you think about a motor that's lifting an object by winding a string around this as it rotates, okay, if they're both lifting the same object through the same height, they will both be transferring the same amount of gravitational potential to that object as they lift it, okay? But if one motor is more powerful, that means it will spin faster and transfer that energy quicker. So more powerful transfers energy in a shorter time or does work in a shorter time. Doing work and transferring energy mean the same thing. So there's lots of other examples of this. A more powerful microwave will cook your food in a shorter time. A more powerful hairdryer will dry your hair in a shorter time. If you're thinking about throwing a more powerful punch, you have to move faster in a shorter time. Okay, but the language is about transferring energy or doing work in a shorter time.